bigger and split it away. But
I think it's time to start. So, my name is Yves Lemay. I'm from Montreal, so my original language is French, but I practice, so it should not be that bad. I'm here to talk about design pattern in LabVIEW. I will show how to implement a way to implement a redundant hardware abstraction layer, which is about what I'll see, and I will show also, I will cover a little bit more why. There are some consequences on what I'm doing. I'm with Averna for 8 years now, and I'm a software system architect at Averna. And I'm also a new architect for more than 10 years. Okay, what we'll see today is I will start at the beginning with a small introduction, the one that sales guy wrote to me. And after that, I'm going to go in the development context and the presentation scope just to make sure that we understand and we use the same wording together. And also to make sure that you understand where I'm going to stop in the logic on the subject I'm covering. A quick overview of the reference that I am using. After that, we're going to go directly in the design and development part. This is where the fun begins, I think. I'm going to show the architecture with ML design, and after that, I will jump on my computer, switch from to duplicate the screen, so there is a chance that you are going to see my family. And after that, I will open LabVIEW and I will work in LabVIEW to show the implementation in LabVIEW. Okay, so that's the thing. If I don't talk too much, I will have time to have a small word on the reusability of what I've done and what can be done from there. And then after that, a quick summary. So far with the practice I've made, I finished there. So I'll try to talk fast. Okay. Okay. I think that's it. Yep. So, first thing. Who is Averna? Averna is an alliance partner with Platinum Alliance partner with NIWeek. We have more than 300 employees. We have 5 offices worldwide. And I may drop a few French words once in a while, so you get brave behind because. Okay. We offer test engineering solution for the entire product from the beginning up to the production line. We also have a off-the-shelf devices in the RF technology. So there are pretty some products that are available on our website. And also, we have also a pretty good team of certified professionals, such as certified LabVIEW architect, test architect, and developers also. Okay. As you can see, we work with clients in many different sectors. So we have extensive experience with different industry challenges and technologies. So if you have a chance, I know it's a little late, but it's at the booth 2 or 3. But I think they decided it at the end of the day, for sure. So. Okay. I was not very comfortable in the sales part. It's not my nature to do this, so let's get started with your situation. Okay. First, I will be developing something concerning on the station. It can be a test station, it can be whatever station you see. So the idea, the concept that I will be using, I will base the demonstration is the station. So what a station, the station is made of a collection of instruments, of tools, and many other abstract objects that we can find. I will focus on the instrument for now. But we'll see at the end that it can go farther than only the instrument. So the station also should provide an interface with the human user. so which we will refer as the client application. And that interface will provide a have a behavior for a certain type of user. Let's say for an operator, it will act in a certain way. For an engineer, it will act into another way, and so on. So with that, the station can also provide, sometimes the station needs to provide some protection on the instrument. Some critical station, they have critical instrument that they will require the instrument that if it's failing, it has to connect on the other instrument that is there to back up. So that's the redundancy. And sometimes also I had to do a station with an application that was able to, because my customer didn't have wanted to be able to remove an instrument, put it onto another station, and after that take the instrument, put it back where it was, without having the software to stop. So that you could just pause the application, remove it, bring it somewhere else, and bring it back and take it back, and it was working. So that's the observability of an instrument. Also a station. By station, I'm talking about the application running the station has to also to coordinate the work that the instrument will do. The collection of instrument is there to will work in a way to achieve a specific goal on the station, and it is one of the things that the instrument that the station has to consider. The implementation of the behavior will focus now on the redundancy and on the swappability of that the station they have to provide. But so far, it was very common to see that this behavior is implemented at the client application level. And that approach, they're going to be using the driver, instrument driver, and if the communication fails, well, in the application level, it will just try to connect somewhere else based on the configuration file and so on. So the behavior, since they are located inside the client application, it gets more heavy to be able to support many different behaviors, such as those that I referred when we change the user type, an operator or an engineer or a technician. Also, when you're doing the work in the application level, when you see that there may be sometimes some issue with an instrument, or there can be some bug with the layer of the instrument, I had to live pretty often, well, a few times, that the expert that developed the driver, they're not available anymore. So you do whatever you can in order to be able to control that instrument and to solve this issue. So which can become costly in terms of time. So it would be nice to have an instrument driver that could just manage itself. So this instrument can detect that, okay, now I'm failing somewhere, so I'm going to disconnect and I'm going to connect somewhere else. And it would be also nice to be able to switch efficiently or with as easy as possible the behavior of a station. And if we could add a station with a specific behavior, and we can have instruments that can manage themselves the redundancy or any other thing. I'm using the redundancy as an example. Then the client application could really become a lot easier to program, and we could really focus on the usability or on the specific domain of expertise that is related with the requirement of the client application. And in order to provide these features, one way to implement it is to use two design patterns that are, how many person here are LabVIEW architect or have a strong experience in that in object-oriented? Okay. So, the bridge design pattern that I will talk about, that I will show how to be implemented in LabVIEW, is able to manage a redundancy management or any other spatial behavior that you will want to have the instrument. And I will also cover the mediator design pattern. which can handle, which can define the behavior of the that the station can have. So with the mediator, it should be able to cover the swappability of the instrument, and also to synchronize or to coordinate communication or action between the instrument also. So this one important note that I have just to underline a lot is that the presentation focuses only on these two things. I'm not going to go inside the detailed implementation of the driver and the client application that is running. Well, it's extremely basic, and the idea is just to focus on really these two concepts. Okay, so I'm not going to show. In fact, I think even the interface, I was about to say a French word. The interface that I have a collection of methods that I have in some of the classes, or they don't even, they're largely incomplete at the driver level. But the other level will cover the concept that I want to talk about. All right. The two design patterns that I mentioned, they come from what they have been largely talked about. And that's a reference there, that's again for the GoF in the presentation title. I refer to the 4 guys on the cover of that book. So for those who didn't have the chance to look at this, and those that really like the concept of abstraction, it's a pretty interesting book to read. Doesn't read it like a roman, by the way. It's kind of dry, but some people like it. So there is 23 design patterns in this, and they're all there to cover, to manage some recurring design problems that we have. And we do have them also in the usually not the client. Those that I will talk about is the bridge and the mediator, as I said earlier. And also in the implementation of the client application that I made, also I'm using the current design pattern, which makes the producer-consumer extremely simple to write. Okay. Typically, in a project, the way people manage the instruments, from my experience, hey, did you hear me well at the back? Okay. The experience that I have is that many developers have used the hardware abstract layer, which is based on an adapter design pattern, which is quite basic, but also efficient. And the typical stuff that we see is that we have the 2 client application here, which may be 1 client application specific for an operator, and the client 2 application can be for an engineer or for a debugger. And these applications, they are using the abstract layer into them so that they can use any type of instrument. But the thing is that in this application, the client 1 or client 2 application, this is the reason why they have to manage the redundancy, because this thing here, okay, it knows that in the code, but at the beginning it will just create the object of the concrete object here. And if this object is failing, well, either you do change how it is implemented there, and then you just violate the idea of the abstract layer, or you just need to manage the destruction and the reconstruction of a new object. Okay. So that's it. And also, in order to be able to detect if an object if an instrument is missing or not, well, again, it's inside the client application that you have to you have to create a thread that may monitor all the way from a long time. That has to monitor the instrument and then detect how it is. And sometimes it can provoke also a problem with exceeding the instrument. Okay. Another issue, which is pretty important, I think, and I think it's the one that has to be the most considered for those that are doing more than one application and that have a bank of driver, is that sometimes in the driver you may for the client here you are going to change this interface for to have some new feature and to add, for whatever the reason can be. By changing the interface here, you will build and do some whatever you need to do, but the thing is that it will impact that thing here. So the client 1, you did it for the client 2, it will impact the client 1. What are you going to do with the back library or the library that now has a new version? So you cannot just simply link with it because the interface has changed. You have to reopen the client code, sometimes consider the fact that it massively changed. And then you recompile the client application and you distribute it. The problem is that if you do this, 90% needs to retest it before giving it a new version. And that can take a hell of a long time. So that's the thing. So I think the third thing there is probably the hardest one to manage. In order to be able to deal with this situation, the bridge design pattern can be pretty useful. Okay, just one thing before I continue. These are UML diagrams. Okay, and I'm going to keep in the presentation. It's only class diagram in the UML, and I kept them as simple as possible. So for those who are not used with those diagrams, these squares are classes. The method of the classes are written inside that section here, and the name of the class is there. So in LabVIEW words, the name of the class, the LV class name is here, and the method here are the VI inside the class. This relation is a generalization to the abstraction, so it means that this class inherits from this class, or in a common language way, we can say that a refined abstraction is a abstraction. This relation here, or this association that we have here, well, means that the abstraction here uses an implementer. Okay? So, and when we see these things, it's because these two classes, they inherit from this one too. So the concrete implementer A is an implementer, and the concrete implementer B is an implementer.
The child?
Yes. Yeah. Yeah.
The arrows pointing up are your inheritance, right? The arrows pointing up are your inheritance.
In this case, yes, I'm trying to do this, but it's, I say that it's a good practice, but it doesn't have to be this way. So the idea is really the orientation of the arrow and the fact that it's this kind of arrow and not this kind of end. Okay, so in the bridge design pattern, we have two sections. There is one section is the implementer section, and this is the architecture. That's the abstract hardware layer architecture. The only difference with the slide before is that I'm showing here two concrete classes instead of only one. So it is that's the whole architecture, and on the other side, on this side here, it is the abstraction side. What's the abstraction side is that it provides just an abstraction of how we are going to use the implementer. Yeah. And these things, it really, the idea of the bridge is really to dissociate the implementation. That means that the client application is going to use this class, as we will see in the next slide. And if anything happens here, yeah, it can be built, but at least it's going to change this thing here, and you will not have to recompile the client application. So I'll show you how it happens in LabVIEW, and it's an interesting solution to solve all of these things. In the refined abstraction, also here, this is where we consider to manage the disconnect, connect, or to destroy or construct the new complete object in the eventuality that there is a failure with the communication. Okay. Now that's the example, the first LabVIEW, on my LabVIEW example. What I'm showing, okay, the color in the diagram are tightly linked with the color of the icon and the color of the wire in the LabVIEW code. So each of these colors, you're going to see the same color in LabVIEW. I try to make it consistent as much as possible. The green section here, we'll see this into the mediator design pattern. So for the bridge design pattern, we have just that section here. In here, I'm only showing the A power supply, as an example, and the redundant power supply here, which will provide the ability to disconnect and connect somewhere else. So how it will do this, I leave it to you. So I'm just showing you where it can be done and how you have to create that view in a way that it can provide this service. That part here is the HAL architecture. So this color is the red color. Here we will have a pack library, and here it's going to be another in the environment of development. It's going to be for the application, the abstract instrument. So I'm going in LabVIEW. We see the A power supply, follow my finger. We see the A power supply class there, which is the one, the A power supply, that has a collection of VI. I will open these VI and we'll have a quick look on all the RDM. The redundant power supply is here. It does have the same interface because the redundant inherits from the abstract power supply. It's just that I have here the managed redundancy VI here. For now it's one VI, but you can make it the way you want. We'll see the details. Okay. And here we have the implementation level, where we see that this is a pack library, and in the project it is used as a pack library, so it can be rebuilt and whatever. And the client application that we'll see will not be impact as long, obviously. That this interface does not change, but there it's likely that it will not change. Also, the abstract power supply here, I suggested as being an abstract power supply, but remember that it is an abstraction. So it can be directly linked with the domain that you are working with, and you may just have a class that will measure the heart rate. And the measure the heart rate will be done with one or many implementer here that are the all, and you will just have to manage them. And so you can do this thing the way it is, the more convenient, and the way it is, the more reusable. The other thing is the mediator design pattern. Okay. In that pattern, well, it provides a way to centralize the coordination of all the instruments. Remember, in the station, the collection of instruments will have to work together. So what will be the one that will be in charge of managing it? Well, with the design pattern, it is a complete mediator. But the thing is that on the other side, the colleague has to know the complete mediator also. So that's a way to do to avoid having to do a cyclic dependency. So you create a dependency at the abstract level. The colleague here has an instance of the mediator, but at that level. So that means that it will just be able to work with the methods that are here. And the concrete mediator here, this concrete mediator knows what the concrete colleague are. And he will have a reference, specific reference of this class or this class, where I actually can have many objects based on this class or on this class. Okay, so and this complete mediator here, it can start a thread, and the thread can can do whatever it wants to do in order to be able to with this to detect and to manage any degraded mode that it can detect. So what does that mean in LabVIEW? And this is the last boring part. After that, I'm going to jump in LabVIEW and try to speed fast, I guess. Okay, the green section is the abstract section. It really is the abstract section. And that section, you will notice for those who will want to have the LabVIEW code, that can be the hell of a good base to start a new framework for, in that case, for a station. But there are some small conceptual and voluntary mistake in that. But not a mistake, it was the risk was the idea was just to be able to make the diagram as light as possible. So we have the station. There is something that describes the station, a station mediator, and an instrument. That class is there to provide a common interface on any instrument that you will have. So the first thing that came up in my mind is the name, the model, provider, serial number, and so on. So it will provide these things. But in addition to that, and that's the mistake I just stated, is the fact that it also provides the ability to connect to the station mediator as to responsibility. And so any instrument and the abstract power supply that I talked about, I just put beside it an abstract spectrum analyzer that has the same architecture as the other one. And so they both here, if we make both of them inherit from the instrument here, we give it the ability to communicate with the mediator. Also, the station here, which has an instance, knows the station mediator, and that would provide the ability of the station to use the station mediator to talk to all of the instruments at the same time. Concrete mediator, the station A mediator, which is a concrete mediator, well, it knows what the power supply or what the instruments are inside the station. So at this level, it really knows what class it's going to be. So in the object collection of an instrument, it knows what it has. So it can work directly with these classes. And I guess that's it. So there is a station A also that will know these things, but the game is playing is really here at this level. So, any question? Yes.
I thought there weren't constructors and destructors.
No, they're not.
Huh?
They don't.
If you have them in your...
Yeah. If we add constructor or developer, it's just a VI. Okay. In here, it really is just a VI that I use to set up the object that I'm creating. It really is just a VI. Otherwise, it would have the same name as a class. And the other one for the C++ guy, it's here with the same name as a class. Okay. So, important thing is the color. Remember just the color in the LabVIEW VI. In the LabVIEw, the same color. I'm using the same color. So now I'm getting inside LabVIEW. I may talk a little bit fast. Let's try this again. Okay, did you see my family? For those interested, you can see me after the presentation. Okay, so first thing that I'm going to show is the green section. So the green section that we have, and also the implementer section, which has the whole side of it. So in the green section, I put everything in the green section inside the LabVIEW library here. And in the LabVIEW library, we can see that we have the instrument class, we have the station class, and the station mediator. In the instrument class, it has, as private members, it has the name, the provider, model, description, and a reference to the station mediator. So that's the the relation that we had with the instrument at the green level, and the arrow was going from the right to the left side. In this thing, we have also a constructor which is extremely basic. So we just set the member, so I'm not going to pass much time on this. The structure also, and these two VI are from the key one inside the architecture. So there's a notify station VI, which is the one. So it already implements how it is going to communicate with the mediator. So whenever you are inheriting from it, you do not have to develop it, because it is in the framework, and it is already defined how it's going to communicate. So you just have to use it. Maybe if you want to rewrite the framework to make it more efficient, then which will happen. Well, then you can define it differently, but it stays at the green level, and it stays inside the abstraction level. So what it does to notify the station, it just comes here, and the media icon here, which is green again, is just the notify instrument in the station mediator. So it calls the thing that will call himself, and himself, when it will be called, it will be managed differently. So that's a way that everybody can be called at the same time without having to use a notifier or any other security programmable program in LabVIEW object-oriented. And the managed notification will be implemented into the concrete instrument. Okay, so that's the instrument, the green instrument. The station now, which is again in the green layer. In the station, what we have, the station knows what instrument it has in it. It's not going to be used in the application, but it's just convenient that the station knows what are the instruments, what's the list of instruments. So we can start by, it can be used, or it can provide the access to the client application to these instruments. And there's also a reference to the station monitor also, because the station monitor is the element that will communicate with all the other objects, with all the other instruments. So it may be useful when you close the application to notify everybody, and then they all close their stuff correctly. In the station, okay, I think that's the important stuff. Oh, so and there's also the get set here. The station mediator now. In the station mediator, there's nothing at the abstraction level. And the notify instrument, which is the one that I opened, that we call here. So it's this one here. So if I open this, I'm following in this one. And this one is being implemented also inside the concrete mediator. The reason of that, the reason the station A mediator is the one that implements it, is because the station mediator is the only one that knows what instrument he's dealing with. Okay, now that's for these. And then there's the power supply and the spectrum analyzer, where we have the INP power supply and the for the spectrum analyzer, the INP spectrum analyzer, which is in the bridge design pattern. So this one inherits from this one, and so on. So that's the usual stuff, but that is being used into the not usual stuff. Okay, once we did define that thing that can be seen as the basis of a framework, then we can just build the stuff here, which will create a pack library in this situation, and this pack library will be available for another project, such as the Station A project. Okay. In the Station A project, we have the instrument and the station. In the station, it's a specific Station A with the class, which is the Station A and the Station A mediator. This is the blue section of the UML diagram. And we have also the instrument. So I'm going to start with the instrument, with the power supply here and the abstract power supply, when we can see that it inherits from instrument here. Okay. And this one here, the redundant power supply, also inherits from this. So inside here we have configure that does not do much other than something very specific to this instrument. And so these are action or react that does work with the instrument. The redundant power supply now, as we saw, there's a managed redundancy. The force error is there just to push artificially an error in the instrument so that I can just validate with the client application. Okay. So in the managed redundancy, it can be called wherever you are communicating with the instrument. Let's say that I'm going to take, that's only that one that I will select. The read state, so if I do come here with the read state, I read the state of the instrument, and I just pass by the managed redundancy PI, which is this one, and in my case, I only pop up a message to show. The message will have also the name of the instance being done, and the model number of the instance, and it will just say that it's managing redundancy at this point. Okay. And so that the managed notification, when we receive a notification, well, it's going to just call this and send another, again, the model number, the instrument name, and the message that says that it received the notification. We'll see where it is. Okay. So as I said also, sending a notification is implemented inside the support in the abstract, which is the thing that we compile with the previous project here and this one here, and the code is over here. I may click a little fast. I'm trying to not go too fast. If it's too fast, just tell me I can slow down for a while. Okay, then the station. With the station, we have station A and station A mediator. The station A here has nothing as a private member, and the station A mediator has only the instrument if for this situation. Of course, we can populate it with whatever we want, but for the sake of the presentation, I kept it as simple as possible. In the station, the meat really is in the constructor of the station. So this is the place where we instantiate the good instrument with the good implementer, with the good, and so on. And in the station mediator, the meat also is going to be inside the notify instrument. So let's focus on the station constructor. This is where the game is going on. Okay. So first thing is that it calls the station abstract constructor, which will, at the abstract level, I just force the to build an array of instruments so that we have an existing size of an array that will not vary in time, and then we can store an object in it, and it will always stay in the same. There will not be any reallocation for that array. So, and that's the main thing that it does, and also it takes the station mediator reference and put it inside this inside the private member also. So in the station A constructor, we call the one of the station constructor. We also use the station mediator like this, and to give the station mediator reference to the instrument also. Before we do that, how we select the instrument is by reading a configuration file. So you can read the configuration file, which here does absolutely nothing except then just hard coding the LabVIEW class that will be used. And I'll code also the abstract redundant. and the IVI power supply, the implementation in using the IVI library of the power supply. So we could have select any HALs, it depends on the configuration of the station can have. So we can start from a configuration file, set up the station that you want to do, and then just do the stuff. Okay, and here I'm just creating the one power supply, a second power supply, and a spectrum analyzer. The power supply is just being set from the configuration file. There's a very important VI that you have to be aware of, and we're casting it into the proper this, because at this level it's an LabVIEW object. Okay, so the thing is the instruments are being created here. They are put into a list or an array of instruments, and the array of instruments here is put in a list, and each instrument are being added inside the list of instruments that we have. If the reference already exists, we destroy it, and otherwise we put it in a good position inside the station. So we have the good instrument list all the time, and it is being managed at the instrument level. Okay, so on the station, really the game is being played in the constructor. For the station mediator, if we open the constructor, it's quite empty. It doesn't do, in fact, I did not even have to create this VI. It's just that I'm lazy and I do create VI to override all of them. So notify instrument. This is again the place where we do use. It has to be done the way you need to be done. This is the place that it has to be personalized to how you are going to notify each instrument. So in this situation, I started to do something here in order to be able to know what position the instrument is in the array of instruments. And from there, I could just select the good thing in the instrument and do whatever I want with that instrument. And after that, I just send a notification to all of the instruments. So when this thing again is just going to use this VI, which in turn will just call that the manage notification. So it's just called the manage. What we can do, we can put any VI at this point that we want to do. So I just made it simple so that it doesn't take me 6 months to create the application. Okay. So at the client level now, I have a main application that will do, when I will start it, it will create, and that's the main application here. So that's the command design pattern that I told you about. So in the producer, the only thing that it does, it's called the execute VI of the command pattern of the command class, sorry. And it will just call that in here. So when we do an action here, when we retract the event, the only thing that we have to do is to create the object correctly, put it in the queue, and when it's being received here, it will be worked out correctly. If we go to any other object, some command also needs to be, you need to have some parameter inside the command so that the execute of the other command is being done accurately the way that it has to be done. Let's say that we want to set a variable and we will pass to it. So the implementation on how things are being done in this application will be located in the commands that we manage in the application. Each of these commands, when we do the initialize, in the initialize, we have a constructor that will take the station name, the number of position, a description, and the station mediator. So we set up these things here, and for the constructor, and the execute that is being called, well, it's just called the constructor of station 8, where it does pretty much work to be done. And how we define what the kind of thing that will be done in the initialize is just here. Well, at that point, we could have used again a configuration file, and we take these values here, we put them into the command constructor, and add it into the, I create the queue also in this VI, which is not specific to the command, it's specific to the client application. So I create the queue also at that point, which has a command as data value, and just put a first value, which is the initialize. So when we come here, it runs at the first time it runs the initialize, and then we can just set up this stuff. Okay. Sometime you will just need to ask for a value, just parenthèse, that's a parent ici. Very good. That's it. Okay. If you want to read the instrument list, like I'm doing when I will click that button here, we have to, we're waiting for an answer. So we send the communication, but it needs to send us back an answer. But there's no direct mechanic, so it has to be implemented also inside the command. And how we are doing that is that inside the constructor, we just create a notifier. And the notifier, we will send the notifier in the execute here. So when it is being done, we just send the value that we know that the command knows what it is, and it will see the answer of the command that it sends. And after that, in the producer version, we have to wait for the notifier while it's waiting for it, and when the value comes, well, it's like this. Of course, my code does not have is not very strong against timeouts and stuff like that, but again, I want to keep it light. So, once everything is selected, we can now easily have the name of the instrument. I can change the model here. I have only one, so I set up the second one. The idea of this demonstration is just to show that we keep the information with the object, and that the reference is not being duplicated, and that we're not losing anything. If I force the error on the first power supply, I know that I receive I manage the redundancy. If I take in that case, it is also being notified, because we may want to close everything. And the second power supply is notified, and the spectrum analyzer also is notified with the good model number also. So if I just do this, and I correct again the same thing, and it has the good model number. So the thing is being changed correctly. Also, if we want to shut down everything, we can just notify all of the instruments directly. That's because of the relation that the station has with, not with the list of instruments, but with the station monitor, with the station mediator. So, I think I passed through almost everything. Which may bring me up to. Okay. Good. Now, the reusability of the stuff that we have under mediator and under bridge. As I said, the station mediator, and instrument can really be, for those that are going to look at it, it can really be used as to define the basis of a framework. It's part of the from a framework right now, but it is a first idea. Changing the concrete mediator inside the station will just change totally the behavior of the station itself, of the station object itself. So you just have to focus on one VI. We have to be very careful with the mediator design pattern. By the way, is not to create a new God. So it must not You must not put everything inside this and end up having an anti-pattern. And it could also be used to communicate with a different class than instrument. And this is, I refer to the error of putting the ability to communicate with the mediator and defining a common interface for the instrument. So having two roles right now, in order to use other classes to communicate with the mediator, we really have to separate these two roles. So as much as possible, we never put more than only one responsibility to a class, and that would be a good example of what to do. The bridge, now, the bridge will just really, because it separates from the implementation and the abstraction, in other words, the way you want to use it with the implementation itself, then you can define it the really way you want to use it and the way you want to have your expert in medical or your expert in IF to do the measurements. So it becomes more intuitive for them to work with it. And you can also add refined management of some stuff the way you want it to do. So the first thing is to define the abstract class of the abstraction side, and then you can implement whatever you want to do. But domain-wise, it can be interesting, so especially for those that are doing application for different domains. So you can just end up having a good library with stuff that talks by themselves, with stuff that say, you can just show the stuff that you have and can easily be connected with existing or with one or many implementers inside the abstraction side. So I just say that you can use more than only one implementer. And abstraction interface also will not change when the implementer does. You just don't change it because the application will have to be rebuilt. So, redundancy, just a quick summary, uses the bridge in order to deploy, to decouple the abstraction with the implementer. And inside the abstraction, this is where we are able to implement the redundancy. This swappability of the instrument, which is managed by the mediator, can be done live, or it can be done live by using a thread inside the mediator. It's just part of the head that stays running, and that can just monitor the state. And whenever something happens, it uses the mechanic of communication with all of the instruments. Instrument class is used by the patient, and the children of the instrument are compatible with the patient. I didn't like that last thing because of the instrument class is okay right now because you define just how it is going to be integrated inside the mediator, but using the word instrument should be rethink because of the double responsibility that it has. Okay. Question? If you feel like discussing about it, or if you want to have the LabVIEW code, it's okay. I can handle the one-to-one English conversation. You have something? No, well, give me a card. Or I can give you my card and just trick me and I will send it to you. I think it's pretty clean. But don't look for robustness, there's none. But the code is so well, can't tell.
Thank you.
Okay.